Hello again. Um, yes, I am from Indiana, but my name is not Jones. So, anyway, haha, lame joke. Here we go. We're ready for section 11-5, dividing polynomials. Dividing polynomials. This one is just a little different maybe from what you've seen before, but I think it shouldn't be too hard. So let's give this a try and see how it goes. So over here on our whiteboard, let's get started. Yeah, let's use red today. I think that'll look a little better. Red should liven it up just a bit and hopefully keep your attention. I don't know. We hope you can keep attention. So we're going to be doing now example number 1. Example number 1. So in example 1, we're taking 8a squared plus 20a, we're dividing by 4a. Now the first thing I would do to solve this is get rid of this divide symbol. You know, it's very seldom in math that we actually use this division symbol here. I mean, we do in assignments, right? But in actual life, we would seldom write it this way. Instead, we would write 8a squared plus 20a all over 4a. This is the way we would write it. In almost all cases, it'll be a fraction like this. So what we need to do now, as always, factor everything that we can factor and see if there are any common factors that can be canceled out. So in the numerator, I hope you can see that there is a common factor there of these two terms. What do you see as common between 8 and 20? Anybody see that 4 goes into both? I would hope so. How about the a squared and the a? You can factor out an a out of both of those. So let's go ahead and do that and see what we come up with. Let's factor out 4a out of the numerator. And we get 4a times 2a is equal to 8a squared plus, okay, 4a times what gives 20a? Well, 4a times 5 will give 20a. And we divide all of this by 4a. And then, as you can see, I hope clearly, these guys cancel out, and we are left with a very simple expression, 2a plus 5. 2a plus 5. Okay, that's your first one, example number 1. Let's move on now, see if we can pick up example number 2. Okay, in example number 2, we take y squared minus 36, and we divide by y squared plus 6y. Once again, the rule, as always, is factor. Let's get rid of that divide symbol. Go ahead and write it as a fraction. That'll be our first step. So we're going to write this thing now as y squared minus 36 divided by y squared plus 6y. Okay? And then that can further be simplified. We can write this then as the difference of two squares in the numerator. So it's, let me just write it here, y squared minus 6 squared, okay, divided by y squared plus 6y. Now in the numerator we can factor that, so this will become equal to y plus 6 times y minus 6. And we're dividing all of this by y. Notice we can factor a y out of the denominator. Y times y plus 6. Like so. Now you can see your common terms. Here they are. Y plus 6, y plus 6. And we are left, again, with a rather simple expression. Which is equal to y minus 6 over y. Okay, there's our second example. Pretty straightforward. Not that much different from what we were just doing in the last video. Almost the same. However, there will be some differences coming up here on this next example, example number 3. It's going to throw something new at you that I doubt you've seen before. So in example 3, we're taking the trinomial n squared plus 3n plus 10, and we're dividing that by n minus 1, and we're going to be using long division, okay? Long division. Why do we need to use long division? Well, the reason is because what are the factors of 10? 2 and 5. What's 2 plus 5? 7. Factors of 10 are also 1 and 10. Sum of that is 11. We can't get the middle term, 3n. So we can't, there's nothing, no way we can factor and then somehow cancel. It doesn't work out. So we use a process called long division. Believe it or not, you can do long division for trinomials or for any other polynomial. You can use long division. It may seem a little weird, but follow along closely, and I think you will be able to make sense of this. The way we begin, we take this term n. We look at the divisor. We look at the first term of that, which is n. And we say, how many times does n go into n squared? So we're looking at these two right here. And we just ask this question, how many times does n go into n squared? Think about it. N times what equals n squared? N times n. Therefore, n goes into n squared n times. So we will then write n right here, okay? Right above the 3n. So keep them aligned. The n's go above the n's, n squareds will go above n squareds, the constants go above the constant. So n goes into n squared n times. Then we take n and we multiply by n minus 1. So we will now take n and we'll multiply by n minus 1. And we get n squared minus n. And we write this, okay, we take the n squared minus n and we write it right over here underneath of this. So it'll be n squared minus n. And then we subtract. N squared minus n squared, no n squareds. 3n minus a minus n is 4n, okay? 4n. And then we bring down our 10 right here. We bring this guy down, and it's positive 10, so we put plus 10 right here, plus 10, okay? And then we ask the same thing again. How many times does n go into 4n? Well, it goes 4 times, doesn't it? Because n times 4 is 4n. So we go ahead and we write now plus 4, okay? And then we take 4 and we multiply by n minus 1, okay? And that gives us 4n minus 4, and we write that right over here, okay? We write it right over here, and then we subtract. So we put 4n minus 4, okay? And then we subtract. What's 4n minus 4n? 0. 10 minus a minus 4. I forgot to put my subtract sign. 10 minus minus 4 is 14, like so. So that's the remainder. Remainder, okay? So how do we go about writing the answer now? So we can see up here at the top that when we divided n squared plus 3n plus 10 by n minus 1, we did the long division, and we can see now that our answer is right there, n plus 4 with a remainder of 14. So how do we write this? The answer is n plus 4 with a remainder of 14. So what we do, we write n plus 4, okay, that's our answer, plus the remainder. But the remainder is 14, okay, divided by n minus 1. That's our remainder. Okay. N plus 4 plus 14 over n minus 1. I don't know if that makes sense to you. It may seem a little weird. Perhaps we should do a little example to illustrate just with plain numbers, and hopefully then it'll be a little more clear. So once again, our answer then would be right here. This is the answer. Okay, this one right here. Okay, that's our answer. N plus 4 plus 14 over n minus 1. Now I'm going to do a little simple example just to hopefully make sure that this makes sense to you. What is, and you'll laugh at this because this is really, really simple, but it's the same idea. What is 11 divided by 4? Well, how many times is 4 going to 11? Almost 3 times, but not quite. So it goes in 2 times. What's 2 times 4? 8. 9, 10, 11. There's 3 remaining. So we'd say 2 plus a remainder of 3 over the divisor down there, 4. 2 plus the remainder of 3, and then we write that as 3/4, 3 over 4. And of course, normally we wouldn't write it like that. Normally we would write it this way, 2 3/4. And 4 times 2 is 8, plus 3 is 11, 11 over 4. So it's 2 with the remainder of 3. So we write 2 plus 3 over the divisor, 3 over 4. Okay? We did the very same thing up here, just it's a little more messy looking, but we got an answer of n plus 4, and then we had a remainder of 14. So we say plus 14 over the divisor, 14 over n minus 1. Hopefully that adds clarity to this and makes sense to you. So let's move on to another example. Try another one. So in this problem, again, we set out to do this division, and again, we cannot factor the trinomial on the left. It doesn't work out nicely for us. So because we can't factor that, we're going to have to use long division. See, hopefully, the way things work out when it's easy and nice, n minus 2 on the right would cancel with something there, a factor of 4n squared minus 3n plus 6. But in this case, nothing does. By the way, I'm supposed to have parentheses around this. Hang on just a second here. Supposed to have parentheses here. Okay. Otherwise, you might think it's 6 divided by n. So I'm supposed to put parentheses. Okay, so we use long division. So n minus 2 goes out front. We put our division symbol here. Oops. Put our division bar here. And 4n squared minus 3n plus 6 underneath. And then we ask ourselves, how many times does n go into 4n squared? Okay, so right now we're looking at this and this first term. And we say, how many times does n go into 4n squared? Well, n times 4 would be 4n. N times 4n would be 4n squared. Okay, so it goes in 4n times because we know that n times 4n equals 4n squared. Okay, so it goes in 4n times. We write that right up above there. We write it as 4n right here. We write the 4n above the 3n, okay? The n's go above the n's. And now we multiply. What is 4n times n minus 2? And what we're trying to do now, we say 4n times n minus 2. and we get 4n squared, subtract 8n. Okay, and that is what we're going to write down up here. Okay. So 4n squared minus 8n. And we're subtracting. What is 4n squared minus 4n squared? Nothing. What is negative 3n subtract a negative 8n? That's negative 3 plus 8. Okay, negative 3 subtract a negative is going to be negative 3 plus a positive. So negative 3n plus 8n is going to be positive 5n right here. And then we bring down our 6 right here. Bring down our 6 plus 6. Now we go and we ask ourselves, well, what about n into 5n? How many times does n go into 5n? And again, the answer is 5 times, because 5 times n is 5n. So we go plus 5. And then we go 5 times n minus 2. Which is equal to 5n plus 10. I'm running out of room. Let me erase this. And write it over a little bit farther. 5 times n minus 2 is equal to 5n minus 10. Okay? And that's what we write right over here, 5n minus 10. That's a little misleading, I guess. This is what we write right over here. 5n minus 10. And we subtract. 5n minus 5n, nothing. 6 minus a minus 10 is 16. Okay? That's our remainder. Okay, 16 is our remainder. So how do we write the final answer? What's going to be our final answer? We're going to write that 4n squared plus, or 4n squared minus 3n plus 6 all divided by n minus 2 is going to be equal to, right up here, this guy, 4n plus 5 4n plus 5 plus the remainder, 16 over n minus 2. There you have it. That is your final answer right there. 4n plus 5 plus 16 over n minus 2. All right, this is long division of polynomials, and it actually does have some uses. There's a use from the last section where we were looking for asymptotes. Sometimes this is useful to see certain asymptotes. And, I won't go there, because if I did, it'd probably just add confusion, and we're almost done with the course. And we're trying to finish up a few things here, so I'm not going to show you. But the reality is that well, I'll just say this. If you look at this thing and you ask yourself, if this was a function, and you ask yourself, what would happen if n became really, really big? Then you can see that 16 over n minus 2, if n is really huge, that goes to 0. The 5 becomes insignificant when n is really, really large. And so this just boils down to 4n, okay? Just boils down to 4n when n is super large. So this thing should have an asymptote, we call it a slant asymptote of 4n. So that could be interesting to look at. Maybe I should do it. Okay, so when I use the Desmos graphing calculator, it doesn't really like other things besides x. So I'm just going to change this thing around. I'm going to write it as 4x squared minus 3x plus 6, all divided by x minus 2. So just change the n's to x's. And let's take a look at this and ask ourselves, what is the asymptote to this problem? Well, first of all, we can't divide by 0, so n should not be able to be 2, should it? N should not equal 2. We can see that right off. So, of course, because we can't divide by 0, then we know n cannot be equal to 2. So if you look down here in the denominator, this guy right here, n should not be equal to 2 because 2 minus 2 would be 0. And we can't divide by 0. So n should not be able to be 2. So that means that n equal to 2, or in our example, I'm going to use x. Just replace all the n's with x's. X could not be equal to 2. X equal 2 would be an asymptote, right? Because that's where the function becomes undefined, infinitely large. Remember, an asymptote is a line to which the graph approaches but never touches. So let's go over here and take a look at our function. I've turned it into a function. So let's call this f of x equals 4x squared minus 3x plus 6. Notice that's just a nice parabola. But if I divide it by x minus 2, okay, it becomes like this, a split thing like this, okay? Going back over here, I'm calling this x minus 2 instead of n minus 2. So the trinomial 4x squared minus 3x plus 6 divided by x minus 2, this is what it looks like. Now, if I turn on x equal to 2, I've already put it in here. Notice that is an asymptote, okay? Really? Is it? Yeah. If you zoom out and if you follow this thing, you will see that the red line approaches but never touches x equal to 2. Approaches but never touches. If you go way, 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 way up, zoom this graph way down here, and you zoom in far enough, you'll see it's getting close, but it's not yet touching. We're up to 108, and we're still not touching, okay? And the fact is, it'll go closer and closer, but it does not touch. So x equal to 2 is an asymptote. But what about this guy? Look along this line here. Is there not the possibility that this is also an asymptote on a slant, on an angle? It looks like those lines are approaching, the other side of the graph is approaching some other line, but what line might that be? So let's go back and look now here. I want you to study carefully, watch. Remember, as the variable gets bigger and bigger and bigger, the graph should approach some line. And it turns out that it's a straight line. Imagine that n is super large right here. If it's really, 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 really big, like huge, okay, 16 divided by a huge number, take away 2. If you take away 2 from a really, really big number, what if n was a million? What's a million subtract 2? 999,998, if I got that right. It's still a really, 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 really big number, isn't it? Taking away 2 from a huge number doesn't change that huge number by very much. And 16 divided by a super huge number is essentially 0, isn't it? So the farther you go out, the farther you make n away from 0. In other words, the larger n becomes, the closer and closer 16 divided by n minus 2 comes to 0, the closer it comes to 0. So effectively, in the extreme, 16 over n minus 2 becomes 0. And when that happens, the question I have, what is 4n plus 5? That's what would be left, right? 4n is a super huge number plus 5. Okay, this looks very strangely like the equation of a straight line, doesn't it? What if I change those n's to x's? Okay, what if I change them to x's? And I called this a function y, and I said y equals 4x plus 5. Okay, y equals 4x plus 5 because this guy plus 16 over n minus 2, this guy right here goes to 0 as n becomes really, really, really big. And we're left with 4n plus 5. And for the sake of my graph, I'm using x's. So you come back over here and you look and see if it bears out to be true. Okay, sorry, it's jumping all over the place here. Here I've made this graph already. I put this in here for you. Notice 4x plus 5 indeed is an asymptote. Look at that. Look at that. Believe it or not, this red line is approaching the green line, and you can go farther and farther and farther up on this graph. You can go way, 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 way up, and it's approaching but not touching. And the same thing is going to be true down below. Okay, very same thing is going to be true down below. You're going to see that it's approaching. Sorry, I need to zoom out, not in. Okay, it's approaching but not touching. Same thing down here. Notice that? Approaching but not touching. Isn't that cool? So look at this. The long division allowed us to find that slant asymptote. By the way, the green line is called a slant asymptote. I'm giving you just a little more than what the book does. But that gives you context. Why do long division? Hey, when you're doing advanced math, it'll let you do things like this, finding a slant asymptote, for example. There are other applications as well, but this is a cool one. And in our next problem, maybe I'll find one more example that I could show this to you. All right, let's move ahead. We've done this example now, long division. The blue part here is just a little bonus, okay? The part circled in yellow here is your answer to your long division problem. All right, let's do another one. So here is example number 5. We're going to take this trinomial 8x cubed, no it's not squared, it's x cubed, 8x cubed plus 6x minus 5. We're dividing that by 4x minus 2. 4x minus 2. So the first thing we're going to do is to write it as a fraction. I'm going to write it like this. 8x cubed plus 6x minus 5. And I'm going to divide all of this by 4x minus 2. And notice that we cannot have x equal to what? 4x minus 2 cannot be equal to 0, because if it was, this expression would blow up and it wouldn't be permissible. That means that 4x cannot be equal to 2. If I take the 2 over here to this side, divide both sides by 4, x cannot be equal to 2 over 4, or x cannot be equal to 1/2, okay? Now, if I were to call this thing a function and look at its graph, it'd be very interesting. What if I just renamed all of this f of x? What if I renamed it f of x, like the following? What if I said I got a little squeeze there. Let me try to move my 8 over a little bit. Okay, that's a little better. What if I called that f of x? And I said, let's do this long division. Let's do this long division and see what we come up with. What if we did that? And what if before we did the long division, we just looked at the graph and said, what does this thing look like anyway? 8x cubed plus 6x minus 5 all over 4x minus 2. How does that graph out? Well, the Desmos graphing calculator is very cool. It allows us to see all kinds of things. So here is 8x cubed plus 6x minus 5 divided by 4x minus 2. Look at this. It's kind of something like a parabola, although it's not really a parabola, but at least it's a curved graph there. And then it has this other funny looking red part on the right that goes shooting off down into the distance below and shooting off up to the right up above. Okay, so it's quite an interesting graph. There it is. So let's go ahead now and do the division and then try to make some meaning out of this. Okay, so what if we do the division? That would be 4x minus 2 being divided into 8x cubed plus 6x 0x squared, there's no x squareds, plus 6x minus 5. So we're going to divide this into all of that, okay? Now notice that we threw in here a placeholder of 0x squared, because we go x cubed, then there's no x squareds, then x, then 5. That's important to keep things lined up. So just throw in a 0x squared there. If you have a sequence like that, counting down with the powers and one of the powers is missing, fill in a 0 for that. Okay, so aside from that little thing, basically everything's the same. We look at this and we say, how many times does 4x go into 8x cubed? 4x times what equals 8x cubed? Well, x times x squared equals x cubed. 4 times 2 equals 8. So how about 2x squared? 2x squared. Let's see if that works. 2x squared. I need to get my pen going. All right, 2x squared. What is 2x squared times 4x minus 2? Okay, that would be 8x cubed. Okay, minus 2x squared times 2. If you're lost, I'm doing this right here. I'm multiplying this now. First I did this times this, and then I do this times this over here. Okay, so 2 times 2 is 4, 4x squared. So, and that's minus 4x squared. Minus 4x squared. And then I subtract. And I say 8x cubed minus 8x cubed, no x cubes. 0x squared minus a minus 4x squared. When you're subtracting a negative, you add. So this just becomes 4x squared. Now I say, well, how many times? Oh, then we bring down the 6x. Almost forgot. Bring down the 6x. So we go plus, I'll do that in red now, plus 6x. Now, next step, I ask myself, how many times does 4x go into 4x squared? Well, 4x times x is 4x squared, therefore it goes in x times. So we're going to say, right here, we're going to go plus, you know what, I didn't get this lined up right, sorry. You'll get the same answer, but I really ought to write it where it belongs. So the first part here is 2x squared, and it should go here. Okay, And then you say 4x into 4x squared goes in x times, so I go plus x. Okay. And then I say, all right, now x times 4x minus 2 is 4x squared. And then x times minus 2 is minus 2x. And then I subtract. 4x squared minus 4x squared is nothing. 6x minus a minus 2x is 6x plus 2x, or 8x. And then I bring down my minus 5. It was supposed to be blue. I bring down my minus 5. So I write minus 5. And now I ask myself again, how many times does 4x go into 8x? It goes in 2 times. Because 2 times 4x is 8x. And then 2 times minus 2 is minus 4. And I subtract. 8x minus 8x, nothing. Minus 5 minus a minus 4 is minus 5 plus 4, which is minus 1. And there you have it. The answer is 2x squared plus x plus 2 with a remainder of negative 1. So let's now write this out. See if we can make sense out of this. And I'm going to write it as a function, okay? Well, not yet, not yet. Let's just write it this way. 8x cubed plus 6x minus 5 divided by 4x minus 2 is equal to 2x squared plus x plus 2 with a remainder of 1 over 4x minus 2. Okay, so there you have your answer as far as the long division is concerned. That is your answer to the long division problem, okay? But now, back to an application of this. What if I said that f of x was equal to this initial thing here? What if I said this? Let me do it in a different color because this isn't actually part of the division problem. It's an application. So what if I said f of x was equal to that fraction, 8x cubed plus 6x minus 5 all over 4x minus 2. What if I said that? Okay. And then I said, well, and that divides out to the following. That divides out to be 2x squared plus x plus 2 minus 1 over 4x minus 2. Okay, it's the same thing. Mathematically, these are equivalent, all right? Mathematically, they're equivalent. So I just simply write this as my simplified, I wouldn't really call it simplified, but it's the quotient. It's after I divide, this is what I get. So f of x equals 2x squared plus x plus 2 minus 1 over 4x minus 2 is my remainder. So what if I do this? Okay, looking back at the graph, look at our Desmos graph a little bit. First off, remember we said that x cannot be equal to what? Right here. X cannot be what? X cannot be equal to, well, let me do this. 4x minus 2 cannot be equal to 0. 4x cannot be equal to 2. X cannot be equal to 1/2. Okay? If you look at the graph, notice if I put in x equal 1/2, that is an asymptote. Believe it or not, that's an asymptote. There's x equal to 1/2. Notice that the graph approaches but does not touch. Approaches but does not touch. Amazing, isn't it? You can actually look at this and see that that is in fact the case. It's approaching but not touching. Same thing as you go down, approaching but not touching. See this as we go down, x equal to 1/2, it doesn't touch it. It just gets closer and closer and closer. However, we still have this other, the rest of the graph maybe also has some asymptotes. Let's think about that. Look at the quotient. The quotient is 2x squared plus x plus 2. So see this guy right here and this right here? What if x becomes really, really, really large? Okay? If x becomes really, 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 really large, this last term down here, this term, try to get a different color, this term goes to 0. Because as x becomes larger and larger and larger, 1/4 times a huge number is really going to be 0. So we're subtracting nothing from this trinomial. So in the extreme, as x becomes very large, it is 2x squared plus x plus 2 is what this boils down to. And if you put this graph in here and take a look at it, 2x squared plus x plus 2, turns out that this other graph is approaching but not touching. It's rather fascinating to watch and to see how this works out. Look at this. So I throw up my green parabola. Is it a parabola? Sure is. This guy right here is a parabola. Okay? 2x squared plus x plus 2. It's a quadratic equation. When I throw that up there, there it is in green. And notice that the red line is approaching. It's really fascinating to see this. It's approaching, but it is not touching. See that? Approaching, but is not touching. And the same thing over here. It takes off after this other red line shooting off over here on the right, approaching, but is not touching. See? That is very, very cool. So we see we can learn things by doing the long division. Sometimes it's helpful to us when we work it all out and we take a look at it on a graph. It helps us to provide some meaning to what we are doing. So I thought I would just share that. That is an application of long division. But be aware that our problem really is solved right here with the yellow circle. This section was to teach you how to do long division with polynomials. And here we've done it. We have that the quotient is 2x squared plus x plus 2 minus 1/4x minus 2 as the remainder. So the yellow is in fact the answer. The yellow circle there is your answer. Well, class, I hope you maybe enjoyed this just a little bit. Did you enjoy it? What? You didn't enjoy it? Come on, guys. This math is fun. I mean, when do you get to do puzzle problems, you know, and sit around and try to work things out? It's fun. Math is fun. I hope you enjoyed it. If you work at it, the more you work at it and the more you learn about it, the more fun it does become. So best of wishes to you as you take on this next section here. Division of polynomials, including long division. All right, best of wishes to you guys as you continue studying. Bye-bye.